This is Mrs. O'Neill for Chapter 3, Section 1, Part 2, Significant Figures. So a significant figure is a digit in a number that is actually known. So there's actually 4 main rules that I follow. However, I believe in your book lists like 6 of them. So anyways, I have a little mnemonic anyways to get you to understand what significant digits are or how many there are in a number, how to decide how many significant figures or significant digits are in a value. So why do we need sig figs anyways? Well, let's look at these numbers, 5, 5.0, 5.00, what do they all have in common? Well, they're all the number 5. However, what's the difference then, or which one is going to be dealt with or measured with the more precise tool? Well, the one that has more of those digits, the one that has more of those decimal places in this case, okay? So the more digits or the more digits that are known, that means probably the more precise tool was used to measure that value. So yes, all of these numbers are 5. However, if I have a mass or a balance and it can only go to that 10th place, or I'm sorry, the ones place there, right? That would be the ones place. It would be 5. But if I have something that go to the 10th place, well, then that 5 becomes 5 point something. And if it's 5.0, then it's measured exactly 5.0. But if I have a balance that can give me 4 decimal places, then I have a more precise tool. It's taking out those measurements a little bit longer in our value. So the more precise tool, the more significant digits there are. So here's the mnemonic. My first thought would be to actually listen to what I say for the memory device, and then maybe rewind and then put whatever you want down. I didn't give you a place to write down the memory hook because people like to write things down in a different way. So first, I like to think of the United States, and I like to think of the Pacific side as the present. The decimal place is going to be present in our number, and the Atlantic side where the decimal place is absent in our value, in our number that we're dealing with. So if the decimal point is present, if you can see it, you're going to start at the Pacific side or the left side of the United States, find the very, very first non-zero number, and then count the rest. Okay, so what do I mean by that? All right, so again, we're going to start at the Pacific side and go to the Atlantic. So if we have a number like 0.045, I'm going to start on the Pacific side and I'm going to go until I see my first number, first non-zero number. And I'm going to say, okay, 1, 2. I'm going to count them all. So this gives me this number, this value is actually having 2 sig figs. So those other zeros don't count towards sig figs. Technically, they're just placeholders. They're just there to show you that it's 0.045 or 4.5 times 10 to the negative 2. Those zeros are just placeholders. So let's try another one. 1.2300. Okay, I see the decimal. It's present, so I'm going to start at the Pacific side of the U.S., and I'm going to go until I see my first non-zero. Well, the first non-zero this time is that 1, and then I'm just going to check them all. All these numbers now are significant. So boom, 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 and that gives me 5 sig figs. So those zeros are significant because they're part of that value, just like those 5.00. If I'm using a balance that masses out to those 4 decimal places, those zeros are going to be really, really significant. Okay, so again, I have the rules in your notes, and I have there's rules also in the book to explain those zeros, but this is the easiest way to understand how many sig figs or significant digits, and I use those terms interchangeably because you'll see them quite often. Okay, so before you write anything down, however, let's look the other way. If the, again, present versus absent for that decimal place, if the decimal point now is absent Okay, you don't see the decimal place at all. You're going to now start at the Atlantic side and go to the Pacific. So you're going to start at the Atlantic, you're going to go until you see that first non-zero number and then keep on counting. So let's see, here's an example. So 230000, I do not see a decimal. So I'm going to start from the Atlantic side, go to the Pacific side until I see my first non-zero number. And in this case, it's the 3. So 3 and the 2, so that would be 2 sig figs. Again, we'll try it one more time. 1750. Okay, so I don't see a decimal, so I'm going to start at the Atlantic and go until I see my very first non-zero number. In this case, it's the 5, and then I'm going to keep counting to the left, 7 and 1. So this would have 3 sig figs. So hopefully that kind of makes sense. And again, now I would pause, I would maybe rewind and listen to this and make sure you're understanding that if the decimal point is present, you're starting at the Pacific side, going to the Atlantic, and then counting all the way through. And if the decimal place is absent, you're starting at the Atlantic and going to the left until that first non-zero number, and then counting all of those digits all the way through. So hopefully that makes sense. And again, we'll have some other example problems and practice problems as well. So hopefully you wrote down all that information. So let's look at rule 1, 2, 3, and 4. 3 and 4 really deal with that Pacific Atlantic memory hook that I just went over, why those zeros are counted or not counted. But rule 1 should make sense to you. All digits that are not zeros are significant. So those 296 are significant, so that would be 2 sig figs, and the 61.4 is also, those are all non-zero numbers, so those are all significant. If there's zeros in between numbers, those are also significant. So 5.029 would be 4 sig figs, and the 306, because those zeros are in between regular numbers, that would be 3 sig figs. So you can read the rule for 3 and 4. Again, I talked about those placeholders, and I talked about that decimal place and using a precise tool. Or what I would do is use that Pacific Atlantic memory hook and see if you can come up with the amount of significant digits in rule 3 and 4. Hopefully that makes sense. Again, it's present, so we're going to start at the Pacific. We're going to go till we hit our first number, which is the 4, and then count them all. Continue going to the Atlantic and count them all. So 1, 2, 3, 4, 5. In this case, however, let's look at rule number 4. Now the, at least this one, this one, the zeros are, it's absent, the decimal is absent. So again, you're going to go starting at the Atlantic. You're going to go until you see your first number, which is only that 7. And this one would be, again, that Pacific way again, okay? So again, there's also online practice. I have this on my website, so you can go there. And I think it just gives you numbers and you check your answers for sig figs. So let's do these practice problems. Pause. Again, the easiest way to do it is doing that Pacific Atlantic, or like for number 1 is pretty easy, and number 2 is pretty easy. But when you're seeing that decimal and you have all these zeros before and after those numbers, if you're getting confused, please, please, please use that Pacific and Atlantic. Hopefully you came up with those amounts. Here's 6 through 10. And hopefully that makes sense. So, rounding. Again, pause. This is a lot of words. Please read as you write, especially this, because there's a lot of words and a lot of information. But this is stuff I'm not going to really go over because you should know how to round. You should know how, if the number is 4 or below, you keep the number as is, or if it's 5 or above, you give it a shove to the next number. So hopefully now you've paused, you wrote down all that information, and again, rounding just like in math class. However, again, pause, fill in the blanks, read as you write. When we're dealing with adding and subtracting numbers and sig figs, we really are going to go by the fewest number of decimal places. This is where it gets a little hairy, a little confusing. So if we look at this first example, we're not going to go by sig figs. We're really going to go by decimal places, even though the problem will always say to you, give your value to the correct sig figs. But in adding and subtracting, we're going by decimal places. So here we go. So the first number has 2 decimal places, the second one has 3 decimal places, and the third number has 1 decimal place. So the first thing we're going to think about is, okay, well, the fewest number of decimal places we're starting with is 1. So our answer can only have 1 decimal place in it. So first we do our real calculated answer. We do all of the numbers and calculate what the real number would be. And now we're going to round the number correctly to the correct number of sig figs. So in this case, again, you told me that it was going to have 1 decimal place to the correct sig figs, but there's a 6 here, so we're going to round up to the 76.3. Now, what is our unit? Again, in science, we're not dealing with numbers, we're dealing with measurements. So if we have a meters plus a meters plus a meters, we're left with meters. Okay, so hopefully that makes sense. Here's another example. So no decimal places there, 1 there and 2 there. So our value, our overall correct answer to the correct sig figs, even though we're dealing with decimal places, is going to be 0. So we're going to do the actual math, all of the numbers in our calculator, and that's what we get. However, we're going to round it to that whole number, right? No decimal places. So that 12, or that 2, I should say, gets pushed up to the 3 because of that 9. And again, a meters minus a meters minus a meters is going to give us meters as a unit. Multiplication and division. Here, ladies and gentlemen, we do go by sig figs, okay? So we're going to do kind of the same thing, but instead of with decimal places when we're adding and subtracting, now we're going to go by the fewest number of significant figures or significant digits in the number. So again, here's our 2 numbers we're going to multiply. We have 3 sig figs in that number and only 2 in that number. So the answer can only have 2 sig figs, the fewest number that we started with. Again, we're going to do the entire calculated number, put all of those numbers in our calculator, and we get this. Now we're going to have to round, though, to 2 sig figs, which would be 17. Now the units. When we take meters times meters, we get meters squared. Okay, so keep that in mind. Example number 2, oh, I apologize, that says example 1 there. Example 2, 31.6 meters divided by 20 seconds is going to give us 3 sig figs there and only 1 sig fig there. So our answer can only have 1 significant digit, or 1 sig fig. Again, do the answer correctly to the amount that would be given on your calculator. Put all of those numbers in, but now we have to round this to 1 sig fig, so we're going to give it a 2. Now, again, meters divided by seconds really looks like this. So we're going to really write our answer, or our unit answer, as meters per second. Meters per second. And that's usually just a slash. So that slash means meters per second, kind of like miles per hour. And remember, this is example 2. All right, so can you do these practice problems? Pause. Again, do the entire number. Use all of the numbers when you're calculating it into your calculator. However, round correctly to the correct, in this case, decimal places. But when we get to multiplication and division, it would be sig figs. So hopefully you got those answers for 1 through 4. And again, I'm reminding you that if you're not getting this or not understanding, please either come see me in class or talk to one of your classmates. So can you do 5 through 8? Again, we're multiplying or dividing. And check your units as well. So hopefully that makes sense. Oh, I have those things there. Aha. I guess I didn't look this over before I played it. But anyways, for number 7, we have centimeters cubed divided by centimeters. So we can cancel one of them out, and we only get 2, the squared on the top there. And the same thing here with millimeters. We're going to cancel one of the millimeters up top to give us 1 left over, and cancel one of the millimeters on the bottom. All right, these are a little tricky. So hopefully this makes sense. You can do the division and multiplying, division and multiplying, division and multiplying. Okay, keep it going. So hopefully you got those as answers to the correct, again, sig figs. And there's our cancellation of units if you need to look at that. Okay, we'll see you in class. And hopefully this will make a little bit more sense when we're doing the bookwork and having our discussion.